Hello, everyone. I'm Scott Salyer, and welcome to the Advanced SQL Server on vSphere breakout session. Hope everyone enjoyed the concert last night. Hope you had a good time, and appreciate you attending our breakout session today. My name is Scott Salyer. The role I serve at VMware is I'm Director of Enterprise Application Architecture. I run a group of architects that focus on Microsoft, Oracle, Java, SAP, those sorts of things running on vSphere. I've been with the company for a little over 8 years, and this is my 7th time speaking at VMworld. Wanda?
Hi everyone, welcome. My name is Wanda He. I'm a Principal Solution Architect with EMC XtremIO product unit. Before working for EMC, I was actually part of Scott's team. I work as a SQL Server Solution Architect for Scott, so I'm really thankful for Scott to giving me this opportunity to present with him together today. Some of you might know me from my VMware days and also know me from my SQL Server days. Before joining VMware, I was actually with Microsoft SQL Server development team, was with their customer advisory team for over 6 years. So,
all right.
Thank you, Scott.
Thanks. So we have the standard disclaimer that is in every deck. You've probably seen a couple of these, so I'm just going to kind of push through since it's the end of the conference and just go straight to the introduction. So on the agenda today, I promise, only 2 slides on why virtualize SQL Server. Everything else is technical. Section 2 is about designing for performance. The number one culprit for performance problems when you're running SQL Server virtualized is storage. And so we're going to spend a lot of time talking about storage design. We'll also cover memory optimization. We'll look at NUMA. And then I'll turn it over to Wanda. She'll go through XtremIO and how that can help enhance the performance of SQL Server and plus some other operational things. We'll cover monitoring and troubleshooting. Then section 3, we'll move on to we've talked about the performance of a single virtual machine. We'll move on to consolidating multiple workloads and how to get the most out of that. And then finally, SQL Server availability. And we'll talk about the new ability to vMotion shared disk clusters in vSphere 6. So why virtualize? Again, just a couple of slides, but I think this is really interesting. We went and looked at our capacity planner data, which is a database that we have that has anonymous data from a lot of different customers. And what we found is that SQL Server database servers account for about 10% of all x86 workloads. It's the most commonly virtualized application, and it might be one of the most common applications in the world. So if you're doing a virtualization project and you're moving towards 100% virtualization, at some point you're going to run into a SQL Server that's mission critical that you're going to have to virtualize. And you want to make sure that you get the best performance out of that. A lot of DBAs, because these workloads are mission critical to the business, a lot of these DBAs are hesitant to virtualize SQL Server. And I'd like to see a show of hands if I can see any DBAs in the audience. Got quite a few, thank you. Thank you for coming. But what we want to show you today is that running SQL Server on vSphere can not only save you money by reducing your server footprint, reducing your licensing costs, but it can also increase availability of SQL Server and also, without sacrificing performance, you can get all these benefits. So a few benefits here. The number one benefit for virtualizing SQL is consolidation. There are other ways to consolidate SQL, and we'll talk about that later in the deck. But it's really easy with VMware. And you can consolidate, reduce hardware costs by, it says up to 50%. Your mileage may vary. That obviously depends on the utilization of the VMs. But that corresponds directly into the first bullet point, which is licensing. So once you've consolidated your SQL servers onto fewer hosts, you can drastically reduce your licensing costs. Anybody attend my licensing session earlier in the week? Okay, great. But on top of that, the management suite brings other advantages, such as database on demand. You know, if you have a situation where you want to auto provision for developers, we have the tools to do that. We have the tools to increase quality of service through HA, through things like vMotion DRS and SRM. And then finally, security, complete isolation between different systems that are running on the same host. So let's dive right into performance. We're going to go directly into storage. I'm going to let Wanda take the next few slides. So please.
All right. So when it comes to storage performance, so think about an I/O coming from application going all the way to the storage. It passes through many components, and each of the application layer as well as hardware layer, there may be throttles implemented at the application layer, and there may be hardware limits. So it's very important to note which layer that you need to tune and which component to watch out for when you are optimizing for storage performance. And we are going to go into the details of it in the next slides, right? QDef is the most common topic when it comes to storage performance tuning, right? So what is QDef, right? Basically, in the SCSI device layer, it implements a configuration option that allow you to tune the maximum number of outstanding IOs per LUNT. That's QDef, right? So when I talk about QDef, I like to use the analogy of a traffic control system. For application I/O traffics, it's more like the local traffics trying to get onto the highway. And the highway is more like the storage system. So what happens when there's a lot of local traffics all trying to get onto the highway? You may overwhelm the highway system, right? Get congestions on the highway. So that's the reason why at the different layers there is implementation of QDef. And the purpose of QDef is traffic control, right? So how does the traffic flows the best? When you have a balanced system, you have a well-controlled traffic. So you have a considerable amount of traffic coming through from the local lanes and merging onto the highway. And so with that, at the hypervisor level, it implements 3 levels of traffic controls. The first level is vSCSI adapter. So vSCSI adapter, you can pretty much think of it as the local streets. How many lanes are you opening up for the local streets? And when you are merging onto the highway, you have on-ramps. And with the on-ramp, on the vSphere layer, it actually has a system called VM kernel admittance policy. So when you have your carpool lanes and your normal traffic lanes all trying to merge onto the freeway, you need to take turns. You need to alternate. And what that VM admittance policy is controlling the alternation of these traffics going onto the freeway, right? And then you have your physical HBA level. That's the actual final control going onto the storage system. Typically, there's default set on vSCSI adapter. Depending on you're using LSI or PVSCSI, each per LUNT, there is a QDef defined. And with PVSCSI, the QDef by default with 5.0 and above is 64, and with LSI is 32. And there's also maximums that you can reach per PVSCSI adapter as well as per LSI adapter. The details of that, I would recommend you to take a look at the KB article, which has all the lists defined for different type of adapters, as well as per LUN limits and per adapter limits, and all of that is configurable. But when you do configure it, you need to be aware that it's a global setting. So you are changing it potentially for all the LUNs that are running on that particular VM. And when you are changing on the physical HBA level, which means that you're changing that for all the storages, whether or not you are running all-flash storage or hybrid storage or multiple storage platforms, it's going to impact all the storage underneath. Right? So the best way to tune it is to know, again, what your highway system, how many lanes your highway system allow you to run, right? What type of storage that you have, what is capability that it can support. And knowing from your application perspective what type of I/O requests that it will demand. That's the best way to tune it. In most of the case with SQL Server running on the storage, the default settings works pretty well, so you don't have to tune it. But in some very extreme cases, especially if you are doing benchmark study and you are trying to push a lot of I/O full, then these are the areas that you will look into tuning. Right? Another important component that will impact your storage performance is your storage network. What type of bandwidth your storage network supports? What type of link it uses? Is it Fibre Channel? Is it iSCSI? Is it NFS? Right? I have customers calling me about performance issues and seeing high latency, and they are running on an all-flash array. And why is that? Well, what we find out at the end is that they're connected to a 4 gig type of Fibre Channel storage network. Well, what happened? Well, basically your bandwidth is being limited by your storage bandwidth. Right, the Fibre Channel bandwidth that you are linking. When you use a different type of storage networks, whether it's Fibre Channel or IP-based storage networks, there are some options in terms of some best practices, how you zoom your Fibre Channel, and how you configure your IP network, whether or not the jumbo frame is being used or not. It will impact the performance on your storage. So that's those are options that you should really look into and talk to your storage vendors and follow their best practices recommendations. And next, I will have Scott talk about the rest of the storage.
Thank you. So let's take a few minutes and talk about VMDK lazy zeroing. By default, when we create a VMDK, we have a lazy zeroing policy. In other words, we allocate the space, but we don't zero out the blocks. We save that for first write. So you place a SQL VM, it comes along, it starts to write to that block. It's got to do two things. It's got to zero it out, then it's got to write the data. And in some cases, we've seen up to a 50% performance hit in writing because of this lazy zeroing policy. There are several SQL operations that can be affected by lazy zeroing. Number one is writes. Writes is the one, that's what's most affected, but also read operations that use tempdb a lot. If you have bulk loads or you have index maintenance, that can really show a lot of performance problems with lazy zeroing. So for best performance, we recommend that you format the VMDK eager zeroed thick. That means that it's allocated all the space up front. You don't have to worry about cycles to grow the space. All of the zeros are written, and the VMDK is ready for first write for SQL Server. If you have a VAAI compliant array, that can take some of that load of zeroing off of the ESX host and put that onto the storage controller. So now we get into SQL Server, and we're going to talk a little bit about data files. This slide, it's a bit of an eye chart. We've got a few best practices, but then I'm going to show you two diagrams that will show you how to lay out the disks for a SQL Server to get the best performance. So for optimal performance, we do recommend that you dedicate a data store / LUN to data files, tempdb files, and log files. All things being equal, you want the absolute best performance, dedicate to those files. Now, by default, when you install SQL Server, data and logs are placed on the same volume. So you may have to go into SQL Server, do the alter database modify file statement to move the log off to another LUN. Data and tempdb can share the same data store because they're both randomized traffic. What you typically want to avoid is sharing data with logs or tempdb with logs. Log traffic is serial and write intensive. Data in tempdb is about 80-20, let's say, for instance, for OLTP, 80-20 read-write. So you want the same kinds of traffic sharing the same data store / LUN as much as possible. So if you have to consolidate, go with tempdb and data together and keep your log files separate. It's obvious you want to stripe data across as many physical spindles as possible if you're not using an all-flash array. It's also recommended that you use multiple tempdb files. And standard practice is to use one tempdb file per core up to 8. I think beyond that, you start seeing performance kind of taper off. So one tempdb file per core up to 8. And the files, this is very important, the files need to be of equal size. SQL Server tends to want to write to files that have more free space. So if I have 4 files, let's say this big, this big, this big, and this big, the third one's going to get hit harder until it fills up and the free space is the same across all of them. So equally sized files are very important for performance to avoid hotspots. The number of data files, it really depends on the size of the database and what kind of backups you want to do. I have seen some blogs out there recommend 0.25 data files per core, but typically it's going to be driven by the size of the database and backups. If you're using storage tiering and you have different speeds of storage, tempdb files go on the fastest. Then you go with logs, then you go with data files. And then for your log data, you typically want to use RAID 10, and you could use either RAID 10 or RAID 5 for data and tempdb. So, best practices are, sometimes it's impractical to design a system based 100% on best practices. You want to get the best performance out of it, but you could run into an issue like here. If I've followed every best practice, I'm dedicating a LUN to every file that belongs to SQL Server. But anybody see the issue here? What's the issue with this? Anyone? Run out of LUNs. Yeah, because not only is this SQL VM using, 10 LUNs here, but it's sitting on an ESX host that's using other LUNs, and every ESX host in that cluster is using other LUNs, and so next thing you know, you're going to run into the 256 LUN limit. So if you want to reduce the number of LUNs, we'll look at that on the next slide. But I do want to point out a few principles that we used here. Now, this is a strict best practices. Most folks don't do this, but we're just trying to show what the best practices would look like. Notice the C drive is, the VMDK may be put on a shared LUN with other OS VMDKs, and we're just using a standard LSI logic, a vSCSI adapter. I want to point out here that we're also kind of mapping out how we're using the vSCSI adapters as we lay out these LUNs. So we use, we have a maximum of 4 per VM. So we're going to put the OS on 1. Then we're going to take a certain set of data files and log files, run those on PVSCSIs 1 and 2, and then PVSCSI 3 we're going to dedicate to logs. Again, for the same reason that we don't want to share log files with data files on a particular LUN. So just to describe the scenario here, we have one database. That's the data file 1, data file 2, et cetera, et cetera. 4 equally sized data files spread across 4 LUNs. We have one tempdb database. Again, we're using the one file per CPU. In this case, we have 4 of them. And then we've spread them evenly across the 3 PV-SCSI adapters. And we've, again, separated out our log traffic into 2 separate LUNs and on PV-SCSI 3. 2 things to point out here. We've used drive letters here, but it can be mount points as well. So that's not an issue there. Let's see. Oh, and you can share log files on the same LUN because they're the same kind of traffic. And since TempDB is usually in simple recovery mode, you might even further consolidate by putting those on the same LUN. So the disadvantage, again, running out of LUNs and a bit more complicated storage management. So let's take a look at one that's a little more realistic. Here we've considerably reduced the number of LUNs. We still have our OS on VMDK. It's going through the LSI logic adapter. We've taken 2 data files and 1 TempDB file on each LUN. And keep in mind that that LUN needs to be sized appropriately to handle the aggregate IOPS of all 3. But as long as you do that, this is an acceptable solution that reduces the number of LUNs that you're using and still separates out the traffic in a meaningful way. Notice that we didn't stack TempDB files together. And the reason we don't do that is because TempDB typically gets hammered more than the data files or the log files. And so what we've done, if we were to stack all those TempDBs together, we could run into an issue where we have a hotspot. One particular LUN is being used more than the others. So we've spread that out across 4 LUNs, co-located with data files so that we can avoid those hotspots. This is one way to do it. This is not the way to do it. This is just to illustrate best practices and principles. There is another way. Oh, sorry. Didn't bring up my animations. Okay. So there is another way to do this kind of thing. You can do it from within SQL Server. You can actually stripe across multiple LUNs and multiple files. We're just showing you the infrastructure-focused or ESX-focused way of doing things. So block alignment is very important, and it's one of those hidden things that can really get you. We've seen quite a bit of up to a 50% performance hit in having blocks misaligned. And you have to do the block alignment both at the host level and at the VM level. At the host level, as long as you create the VMDK from within vCenter, then it should ensure that the VMFS blocks are aligned. But at the operating system level, Microsoft has said, 2008 and above by default is aligned correctly. That being said, there are examples where if you buy a server from an OEM vendor, they might have a recovery partition that results in a undesirable starting offset for the Windows partition. So Microsoft recommends that you at least go in and check, especially if you're having a performance problem. So I have one slide on memory optimization, and it's really around using large pages. So we recommend that you use large pages both at the ESX level and at the guest level. And why is that? Large pages reduce TLB misses, and at the ESX level, large pages tend not to swap. Swapping is bad. Whenever something goes to disk, that's when performance tanks. So you want to avoid swapping at all costs, and by using large pages at the host level, those large pages will tend to break into smaller memory pages before being swapped to disk. It gives you an extra level of protection. In the guest, we recommend that you use large pages, and that can be done a couple of different ways. If you're running 2012-2014 and you enable the lock pages in memory user right, if you grant that to the SQL Server service and the VM has more than 8 gigabytes of memory, then that will turn on large pages for that guest. In the past, older versions of SQL Server, you had to start the SQL Server service with a trace flag in order to achieve it. So a couple slides on NUMA. Check time here, make sure. So NUMA is an architecture by which it was developed basically so that in a multi-processor system, two processors aren't trying to use the same bank of memory. So what we've done is we've dedicated banks of memory to each processor, and it's supposed to increase speed. Now there's this thing called NUMA crosstalk, and NUMA crosstalk happens when processor 2 needs to access memory that's on processor 1. So it has to make a hop over to that processor to get to that memory. And that causes a slight performance hit. And then you can see how over time that could aggregate into a large performance problem. ESXi is NUMA aware. And when we say NUMA aware, it understands the NUMA architecture of the physical server. And if the virtual machine fits into a single NUMA node or socket, then it will do its best to run that NUMA node on that or that VM on that socket. SQL Server is also NUMA aware, but there's a setting in vSphere you have to turn on in order to allow SQL Server to see the NUMA architecture of the ESX host. So a few NUMA best practices. Again, just like dedicating a LUN to a file, that's the ideal. So the ideal is to avoid remote NUMA access. If you have 4 sockets in a server, and you could run your SQL Server within one socket, then you're going to get the best performance because there's no NUMA crosstalk to worry about. So basically, you're running the VM. It needs to be either the number of cores on the socket or less to run inside of a NUMA node. For what we call wide VMs, that's VMs that need more cores than there are in the socket, you want to do a multiple where possible. So if you have 4 cores per socket, then you want to make the VM use 8 cores so that you're covering 2 NUMA nodes. And then on top of that, you want to use VMware Virtual NUMA in order to enable NUMA awareness to the guest operating system. Hyperthreading is something you need to take into account. We recommend, since hyperthreading only gives you about a 10 to 25% benefit in performance, we recommend that you do your initial sizing conservatively and size by cores. And then once the workload has been sized correctly, turn on hyperthreading to get the extra 10 to 20%. The last bullet, if you're vMotioning, you'll get better performance if you move between hosts that have the same NUMA architecture. So again, a bunch of best practices and then a diagram. This is what a non-wide VM would look like, both with hyperthreading off and hyperthreading on. And I don't know if the diagram's clear, but we have a socket with 12 cores and 24 threads if we turn hyperthreading on. So on the left, we have a SQL Server that has 12 virtual CPUs, and each virtual CPU corresponds to a core. On the right, we've turned on hyperthreading. Now the SQL Server sees 24 vCPUs, and each one of those correspond to a thread. Now, the one thing to point out, and I mentioned this in my licensing session, you'll get 10 to 25% extra performance, but you're paying double the license because you're paying for each thread when you license SQL Server. So definitely keep that in mind and make sure that it is a mission-critical workload worthy of that. Now, a wide VM is one that spans multiple NUMA nodes or sockets. So here we've got a 24 vCPU SQL Server. We've turned hyperthreading off just for simplicity. It's using 12 cores on one node, 12 cores on the other, and we've turned on vNUMA. And what vNUMA does is it extends NUMA awareness to SQL Server, the guest OS, and SQL Server. vNUMA is not compatible with hot add. You can't use the two features together. Okay, I'm going to pass this back over to Wanda. We're going to talk about flash storage for a bit.
All right. So When we talk about SQL Server virtualization to DBAs, we get the response. A lot of DBAs are still concerned about performance on moving SQL Server from a physical dedicated environment to a virtual share environment. And while moving to virtualization, provisioning a SQL Server box is so much faster and easier with VMware, but deploying copies of database is still very time consuming and also storage resource intensive. So how can we help from a storage perspective? And that's what I'm going to focus on talking to you about in this XtremIO enhancement session, right? So what is XtremIO? XtremIO is an enterprise all-flash storage array with a rich set of built-in data services. When we talk about flash, maybe everybody will immediately think about performance. Yes, performance is definitely the number one reason why you want to run your SQL Server workloads on all-flash. But it's not just performance. It's much more than performance. It's also the efficiency as well as the simplicity that an all-flash array like XtremIO can offer to you. And when we talk about performance, right, with XtremIO, the key is consistent low latency with any scale. And when we say any scale, it's because XtremIO is developed on a scale-out architecture. And what it means is that you can always start small with your small virtualization environment. And when your business grows, you need to expand your vSphere cluster. And you can expand your storage from a performance perspective and from capacity perspective along with your virtualization environment. And when you expand by adding additional X breaks, you add additional performance as well as capacity. Each of the XtremIO X break can give you about 250K, 100% read IOP performance. And if you run mixed workloads, it can perform about 150K mixed read-write workloads. And we can scale all the way up to 8x break now with our recent 4.0 release. So that's over millions of IOPS for your virtualization environment. And what's important is that as you scaled, your workload is automatically distributed or rebalance across all the SSDs, and you're guaranteed to get the performances of the entire cluster when you expand with any of the SQL Server workload that you deployed. And also has a rich set of data services that's built in to the storage. It's free to you. So what it means is that now you can reduce your SQL Server on this footprint without running data compression feature with SQL Server, and with its copy data services, you can easily deploy any test def copies or any type of reporting copies, any copies for repo tuning or whatever reason that you need to instantly without consuming additional disk space. And because XtremIO is so easy to use, it has built-in array configure, and it automatically manages performance for you by balancing the data across the entire cluster. So provisioning for SQL Server is so much easier. And I know that as a DBA, I used to keep very complex spreadsheets to keep tracking about capacity planning, sizing for my SQL environments. But with XtremIO, you can pretty much forget about that and toss your spreadsheet away. Provisioning SQL Server is extremely simple, which we're going to look into later as well. So this is a study that we did in the lab. What we did is that we started with a single SQL Server VMs running an OLTP workload with a database about 1 terabyte. And we gradually add additional VMs onto the system, and with 2 VMs, 4 VMs, and up to 8 VMs. As the number of VMs increases and the consolidation increases, and the databases are competing for storage performance, we want to see how the storage scales and how the latency holds up from a performance perspective. So on this graph, you can see that with a single SQL Server VM, we generate about 22K IOPS. And with 2 SQL Server VM, the amount of IOPS scales up fairly linearly, about 45K, and 4 VMs is 95, and up to 8 VM, it's about 180 2K IOPS that's generated total. And what's important to point out is that if we look at the latency graph there, the latency stays very low, below 1 millisecond. In fact, it's around like 500 microsecond level. And even though the IOPS are really scaling up fairly linearly all the way to 180K IOPS. Right? So really, what it says is that when you consolidate your SQL Server on XtremIO, you can safely count on the consistent low latency performance that the storage provides to you. And this is an actual customer deployment case. So they are measuring the SQL Server batch runtime before and after migrating their workload from traditional storage to XtremIO. And they were able to reduce the batch runtime from 7 hours to 1 hour without any tuning, and just by migrating the workload to the XtremIO resource. And really that opens up a lot of opportunities for them. Now that they have 6 hours of compute resource, they can repurpose for other uses. And they can run more workloads, and they can even maximize their investment on SQL Server licenses by spinning up additional SQL Server VMs. Right. So I often hear storage admins complaining about DBAs asking for disk space but never use them. But coming from a DBA perspective, I know why that's the case. Right? If you do storage planning as a DBA, first of all, you need to project for your database growth, probably like a 3-year projection for the potential database growth. And you need to allocate space for your database, because for a database file to auto-grow during peak time, it's a big performance hit, right? So that's why you ask for so much storage space. But a lot of time what happens is that all this storage space ended up wasted, and for a long time, right? So with XtremIO, while the storage admins can continue to give out storage space, and the database administrator can just do their capacity planning the same way. On the physical storage, the on-disk storage that actually gets used, it's much lower, right? XtremIO has built-in thin provisioning as well as zero optimization, which means that it never stores zero. So none of the allocated space takes any physical space. On top of that, it has global inline dedupe and compression. So it only stores unique blocks onto the physical media. And before the data block gets stored on the media, all the repetitive pattern gets removed. So it's compressed as well. So when it reaches the physical storage, it's automatically guaranteed to be with its smallest on-disk footprint. Right. So earlier, Scott has talked to you about storage performance, how to optimize it with having multiple LANs, multiple SCSI adapters, configuring it for the different type of RAID configuration depending on the type of files, and separate your data from your log, from your TempDB, and having like multiple lines for TempDB. Now I'm going to ask you to forget about that for XtremIO. And why is that? Well, because XtremIO has built-in RAID configuration, so you don't have to worry about RAID anymore, right? Any data, the data on any LAN is automatically evenly distributed across all the SSDs within the cluster. So you're guaranteed to get the performance of all the SSDs no matter how many LANs you have. You don't have to worry about the number of spindles that you have back in your LAN, right? What's the reason to separate data from log on traditional storage? The reason is because like data and log has different access patterns. Some are sequential, some are random, some are large block, some are small block, right? But with XtremIO, it's all fresh. Data, XtremIO uses content addressing. Data is randomly placed across all the SSDs, and it doesn't matter whether or not it's sequential or it's random, large block or small block. You are automatically taken care of. So all you need to do is to specify how much capacity that you need. And that's all you have to do to provision for your SQL Server. Okay. After your SQL Server moves on to production, it's just the beginning of a SQL Server life cycle. And you still need to continue to develop, to test additional features. You need to tune your SQL Server to make sure that ongoingly it performs well. And you need to check your database integrity and do backups and upgrades and all that, right? And many of those type of actions, you wish that you would have a copy of the production database. So when you develop a feature, it minimize a lot of risks for rolling out new features onto production when you develop on production copies. But in reality, there's a lot of challenges for doing that. First of all, where can you find the disk space? It takes a lot of disk space to hold up copies of production database. When you do find the disk space, it's probably on a very much slower storage than the production, so you can never see the same behavior as production. Right? And when you make those copies, it takes a long time to create a copy. Who has experience of deploying copies of production database and like to share some experience with us? Anyone? No? Anyone has ever deployed always on secondary replica? Yes? How long does it take for you to deploy an always on secondary replica? Quite a while. Is it like minutes, hours, days? Hours. All right. So I'm going to show you a demo of rapid deployment of always on secondary replica. And give me a minute to set this up. All right. So I have a SQL Server environment here. And SQL Server 1 is my primary VM, and SQL 2 is the VM that I'm going to deploy a secondary replica on. Right. My production SQL 1 database, it's about 900 gigabytes. Right. And I have 40 terabytes of space provision currently on the storage. On the physical capacity, it's actually used much less, 1.224 terabytes. And my current storage efficiency is 32:1. So I'm going to follow like the typical steps to deploy an always-on like secondary replica. The only difference is that instead of using the traditional backup and restore method, I'm going to do a snapshot backup. And it's a 5-step process, and I'm going to use a tool called EMC AppSync to do application consistent backup. So log on to AppSync. I have a service pane created for taking the snapshot backup. I'm going to use that pane, and it's going to go ahead and take a snapshot, application consistent snapshot backup for me. And this is going to take about a minute. Once the backup is taken, I want to back up the active log as well. So using the same service pane, I can back up the active log. Now I have the log backup. I'm ready to create a secondary replica. I'm going to mount the snapshot onto the secondary database instance. And when I go to AppSync to mount, I mount it to SQL 2. Right now, it's important when I mount to say when I want to recover the database, I only want to do partial recovery. Because as you know, with always on, you need to recover the database partially so it can continue to receive log backups. So go ahead and say recover the database in no recovery mode. When that's done, I'm ready to restore the active log on the replica. And that I will go to SQL Server Management Studio to run a script to just restore the log. Very quickly, now I'm ready to create an always-on relationship. So now I'm going to create an always-on relationship. And in this relationship, I will create it as synchronous commit with readable secondary. So this is more of a local HA with a readable secondary type of scenario. Because I already done the legwork of backing up the log or restoring the log and restoring the database and the log, right? So all I do is to say, okay, create a relationship and also do the initial synchronization. And now if I look at the always-on replica that I created, it's fully synchronized. Well, let's go back and look at how the storage consumption is. While I provision additional 1 terabyte of storage, the physical capacity only increased very kind of tiny bit. And the overall efficiency increased from 32:1 to 33:1, right? And don't forget that while this is going on, I have a 60K read-write workload going. And if we were to look at from a storage volume perspective, the first volume on top, that's my primary replica volume. The second volume is my secondary replica. Let me go back a little bit so you can look at it. So you can see that while the primary volume is going on for running about 56K IOPS per second, there's only little IOPS going on my replica volume. Right? So in less than 5 minutes, I just deployed an always-on secondary replica of near 1 terabyte database. All right, I'm passing the speaker back to Scott.
How do we switch back here, Wanda? Okay, there we go. Great. Okay, so we get calls all the time from customers that they ran a SQL Server in physical, they wanted to virtualize it, and suddenly they ran into a performance problem. And the first thing we hear is, it's VMware. It's VMware. It worked fine before, now it's on VMware, now it doesn't work. And what we want to demonstrate here is that this is an entire stack. That if you're looking for performance problems, you want to make sure that you troubleshoot at every layer of the stack. And if you call GSS, they're going to start at the ESXi layer, and they're going to work up to the application guest OS, and they're going to work down to the storage. So because storage is so important, and because we can't talk about every single counter out there, we're going to cover performance counters for storage that might be useful to you guys when you're troubleshooting problems. We've got 3 counters: G average, K average, and D average. And these are brought up through the ESXtop command line interface. G average is the I/O latency in the guest, the I/O latency that the guest sees. K average is the latency of I/O passing through the ESXi kernel. And then D average or device average is latency at the device level, and it includes round trip time between the HBA and the storage. Now, that being said, G average and D average, top and bottom, the investigation threshold there is about 20 milliseconds. You can see maybe a spike here and there, but sustained activity should be less than 20 milliseconds for those counters. When you look at kernel average, though, it's a lot more sensitive. We recommend an investigation threshold of 1 millisecond there, because it's a very bad thing if commands are queuing up at the kernel. Great KB article that tells you how to use all this up in the upper right-hand corner. Of course, as you DBAs know, there is no difference in monitoring SQL Server at the SQL Server level, whether it's a VM or whether it's physical. You can still use perfmon, extended events, profiler, etc. So looking a little bit at consolidation. So the traditional approach for consolidation was to have a large SQL server and put multiple instances on that SQL server. Why would you do that? Back at the very first slide, we said most SQL servers are under 20% utilized. So that can be an extreme expense for both hardware and the licensing costs. So before virtualization was even an option, the method on the left is what most customers used to consolidate. Single server, single operating system, multiple instances per VM, maybe even multiple databases per instance. So anybody see a problem with that? What's the biggest problem with running multiple instances on a single physical server? Anyone? Say again? Oh, that's actually a good one. I hadn't thought about that. If you had separate DBAs managing the different databases, then that could be an issue. I think the main issue here, though, is the fact that one database or instance could take over all the processing and memory on the box and starve out the other databases unless you use min server, max server memory settings, which can be complex if you don't understand them, or SQL Resource Governor. Not that those tools aren't completely acceptable and usable and great. This is one approach. The other approach is more of a virtualization-centric approach, and that is single instance per VM. And that by doing that, you've essentially isolated that database from performance contention. You've made it a small VM, so it's easier to move around the enterprise. It's easier to manipulate, easier security and change management, but could be a potential increase in DBA management activities because they're having to go to multiple operating systems to do their work. That is one potential drawback. Now, just like all our best practices, no one goes with all one or the other. You're going to see some mixture of this in your environment. Sometimes it might be best to scale up. Maybe those databases are related. Then in some cases it might be better to scale out to get performance and utilize vSphere features in a meaningful way. So running with mixed SQL Server workloads, you need to take into account a couple of different things. First of all, look at the workload characteristics. And those characteristics will tell you what the average utilization of the virtual machine is, or the virtual machines, and will give you the option to manage over subscription if that's even an option for you. And then also consider operational history. You know, some SQL servers are barely used except for at the end of the month when they get hammered. So consider operational history when you're placing workloads on your ESX hosts, and I'll give you a great example of that. Both of these say average 15% utilization. The top one is an OLTP workload. It runs during the day. The bottom one is a batch workload that runs at night. Now, if you were just looking at 15% utilization, you might miss out on a consolidation opportunity. But the fact that we're looking at the time of day it's running, these are perfect for each other. One runs when the other one's not, and vice versa. So now we can maximize our consolidation, maximize our licensing costs, and do absolutely no impact at all to performance for both virtual machines. So I'm cutting it close. A couple slides on availability. Skipping that one. Support for Microsoft clustering in vSphere has changed. It used to be that, now you still have to use raw device maps or RDMs for cluster nodes for the quorum disk, but the thing that's changed now is that you can vMotion those in vSphere 6. So, and we'll look at a diagram in a second to see what that means, but shared disk clustering, or SQL Server SCI, it is now supported in vSphere 6 to vMotion those cluster nodes. And of course, non-shared disk clustering or always-on availability groups have always been able to. So vSphere HA with shared disk, we have a shared quorum disk. Each operating system has its own disk. The way HA, or the way it works with vSphere HA, hang on, let me back up. Got a little bit off track there. All right, for shared disk clustering or FCI, we support up to 5 nodes. But again, we only support RDM for the cluster quorum disk. We can't share VMDK still, but again, you can vMotion that. But what I want to point out on this slide is that clustering is great for workload failover, but what happens in a physical world if I lose one of those cluster nodes? One of the cluster nodes goes down, failover happens, it goes to the secondary, and then how long does it take me to replace the failed cluster node? Who's got a 4-hour replacement with their vendor? Who's got an 8-hour replacement with their vendor? A couple. I saw a couple hands. Most people, it's going to be days. And while that secondary node, or while that primary is down, and you're running on your secondary, you are introduced to further risk if that secondary goes down. The second problem is when the primary comes back up once it's been fixed, now you got to resync. So we believe that vSphere HA and failover clustering work well together. What we're saying here is, I lose a host, it's down, I reboot the failed VM to another host, I'm back up in 2-3 minutes. I'm no longer subjected to further failures. I no longer have high reseed times. So vSphere HA in conjunction with failover clustering. Same thing with always on. Always on is just a different model. We don't use a shared quorum disk. Now we use a file share witness, and replication happens over IP. So not only can I use HA in the exact same way I use with FCI, but you know, again, regardless of vSphere version, I can vMotion always on availability group cluster nodes. So that's all we got. Thank you.